So in this example, we're asked to find the volume of revolution formed by rotating the curve y equals 4x minus x squared on the interval from 0 to 4. And we could most definitely find this volume probably by doing disk, although it's a little impractical, right? I mean, because if you think about the way we might form a disk right here, if we had to do so, would be to form that disk by going between, well, the same curve from left to right, right? And that means that we might have to rewrite this thing in terms of dy, and well, that's kind of a pain, right? It's completing the square, all kinds of not fun stuff that I know that everybody says they hate. So let's try something else. Let's see about forming a shell. How would we do that? Well, what we're going to do is we're going to consider a shell formed with a dx strip and rotate it about the y-axis right here. What could we say about it? Well, we see that shell right here. If it's rotated about the y-axis, we're kind of going to get this volume in each case. What should it be? Well, we know that the thickness is going to be dx. And our rule stated that essentially we were going to find a volume using the shell method here with dx strips by taking 2 pi on the interval from a to b, whatever a and b is, of r, our radius, times our height, f of x, times dx. All right, so what should we form as our radius? Our radius is going to be the distance from our axis of rotation to the curve right here. Let me put that in a different color so we can show it up here. All right, so that r for us is going to be equal to x. Okay? Okay, how about the height? Well, the height is not too bad, right? Because our height, f of x, is going to be formed with our curve. F of x equals 4x minus x squared. And we're told to find it on the interval from 0 to 4. So that's where we're going to go right here. So let's see how this one works out. If we put this together, our volume using this shell method is going to be found as 2 pi times the integral from 0 to 4 of the quantity x, which is our radius, times f of x, 4x minus x squared dx. Well, this is actually not a bad one to work with, right? Because now we know we're going to take 2 pi and we're going to be integrating a function that we probably know pretty well at this point, something like 4x squared minus x cubed dx. So let's see, let's work this through. 2 pi, what do we get right here? This is going to be 4/3 of x to the third minus 1/4 of x to the fourth. Let's see, that's going to be 2 pi and 4/3 of 64 minus 1/4 of 4 to the fourth. We can simplify down on that a little bit. Let's see right here. 2 pi is going to be multiplied by, let's see, 4 times 64, 4 times 4 is 16, plus 4 times 6, 240, so 256 thirds. And we're going to subtract from that 1/4 of 4 to the fourth, well, that's 4 to the third, right? So minus 64. And we're going to multiply the numerator and denominator of that by 3 to get a common denominator right here. Right, so let's see if I work that through. 64 times 3 is 4 times 3, which is 12, plus 60 times 3, which is 180, so that's 192. All right, so we've got 256 minus 192. Oh, that looks like a 74 to me, maybe. We multiply that by 2. 74 times 2 is 140 plus 8. So we've got 148 pi over 3 as the volume of this solid that would be found. So that's how we do it. That's what we're doing. A little number work here, but not too bad, right?